In this video, we are going to be discussing isosceles triangles. You might already know that an isosceles triangle is a triangle that has two congruent sides, and we're going to add a little bit to that knowledge today. So first up, we have what's called the isosceles triangle theorem. It basically says that if two sides of a triangle are congruent to one another, that the angles opposite those sides are also congruent. So while we often think isosceles triangle is one with two congruent sides, we should also note that it additionally has two congruent angles. Here's what it looks like in terms of a diagram. If this triangle is isosceles and it has two equal sides as shown by the tick marks, then the angles opposite those, so I like to sometimes draw these arrows in to help me see what angles are opposite, those angles also are of equal measure or congruent to each other. Okay. And then let's just add some vocabulary on here. The base angles, those are the congruent angles of an isosceles triangle. And the vertex angle is the non-congruent angle in an isosceles triangle. So just to label those on our diagram here, these two angles at the bottom, they're congruent ones. Those are the base angles. And the bottom of this triangle here is also called the base. The vertex angle is up at the top. That's the non-congruent angle. And if you don't remember, the two congruent sides of an isosceles triangle are called the legs. So let's examine some problems that relate to isosceles triangles. If we take a look at number 1, it says find the measure of the vertex angle. Okay, so that means we're looking for this angle up top here. Well, first, let's figure out what the other base angle is. Using the isosceles triangle theorem, if this angle is 42, this angle is also 42. So I'm going to go ahead and fill that in. Then we know that in a triangle, there's an interior angle sum of 180 degrees. So if I add up 42 and 42, subtract from 180, that makes the measure of this vertex angle 96 degrees. Okay, let's take a look at number 2. Find the missing angles in the triangle. In this problem, we are seeing that the isosceles triangle has been rotated a little bit. So the base is not actually on the bottom here. So I'm going to go ahead and I'm going to draw those arrows back in to just help remind me what two angles are congruent. And I see it's the two angles that are unmarked in this picture. So what I'm actually going to do is I'm going to subtract 94 from 180, which gives me 86. And then I'm going to split that against the two angles. So I know that each of the missing angles in this picture have a measure of 43 degrees. All right, number 3, in an isosceles triangle, the base measures 4 centimeters and one leg measures 3 centimeters. Find the perimeter of the triangle. So let's draw this out so we can see what we're looking at here. The base is 4 centimeters. One leg is 3 centimeters. Well, we know in an isosceles triangle that the two legs are congruent to one another. So I know that this is 3 centimeters over here as well. The perimeter is the sum of all of the sides of a shape. So I'm going to add them up, 3 plus 3 plus 4, and I get a perimeter of 10 centimeters for number 3. All right, moving on. Number 4, in the picture below, name the base angles, just practicing the vocab here. So the base angles would be angle A and angle C, whereas the vertex angle would be angle B. In number 5, what is the measure of angle C? Well, we see that we're looking for the other base angle, so it has to be congruent to the one we already know, so 47 degrees. Number 6. In triangle ABC below, ABC and BC are congruent. If angle C is 75, so I'm going to go fill that in, what is the measure of angle B? Well, angle A and angle C are going to be the two congruent angles in this triangle. Again, they're the ones that are across or opposite from the congruent sides. And then I'm going to use my interior angle sum to find the measure of angle B. So that gives me a measure of 30 degrees. This question is a good reminder that not every picture is drawn to scale. That angle at B definitely looks like it's obtuse, so remember we don't want to assume anything is drawn to scale. Number 7, what are the measures of the two acute angles in an isosceles right triangle? Okay, so I'm going to draw this out to take a look at it as a visual. If it's isosceles, we know 2 equal sides. If it's a right triangle, we know that one of the angles is 90 degrees. These other 2 angles are going to be our congruent ones. So I know they are each going to have a measure of 45 degrees because the triangle itself has to add up to 180 degrees, and those 2 have to be congruent. So basically what I'm doing is I'm taking 90 away from 180 and then splitting it amongst the 2 base angles to get each one with a measure of 45 degrees. Number 8, in an isosceles triangle JKL, J is 50 degrees and K is 50 degrees. Name the 2 congruent sides of the triangle. Anytime there's not a picture, I would always recommend drawing one. Even if you feel like your picture's drawn inaccurately, that's okay, as long as we can kind of get a visual of what we're looking at and what we're talking about. So angle J is 50, K is 50. Based on that, I can see that, yes, this triangle is isosceles because it has 2 equal angles. And that means 2 of the sides are going to be equal or congruent as well. So we just have to figure out which ones. So the converse of the isosceles triangle theorem is also true. That means if you have 2 congruent angles, the sides opposite them are also congruent. So now I know that JL and KL are going to be my 2 congruent sides. All right, for our last problem on isosceles triangles, we have one that is algebraic. Once I see these algebraic expressions, I know I really am going to have to write an equation and solve. Before I do this, I'm going to first figure out what angle L is. I don't like that it's blank in the picture. I want to fill it in with some sort of label. And that's where I'm going to use the isosceles triangle theorem and say that it also must be 5x minus 10, since it's the other base angle of this triangle. Once again, I'm going to use the rule that the angles in a triangle add up to 180 degrees. And I'm going to take all 3 terms, write them up, add them up to 180. All right, let's combine like terms. 20x minus 20 equals 180, and then let's work to isolate the variable. So 20x is equal to 200, and we get that x is equal to 10. Hopefully this lesson helped you better understand isosceles triangles.